So we're going to look at solving side-side angle triangles, and this is called the ambiguous case sometimes. If you think back to proving triangles congruent, using side-side angle will not allow you to prove one triangle is congruent to another, and there's a good reason for that based off the information you might have. We're going to look at this by three cases, and the first one we're going to call case 0. So we have triangle ABC. We're given angle B is 70 degrees, little a is 6, little b is 2. And maybe you're having a hard time recognizing whether or not something actually is a side-side angle. We're given angle B, we're given little b, we're given little a, and now if you look at those markings we can see maybe a little more clearly that this is in fact a side-side angle scenario. The way that we would solve one of these side-side angles is to use the law of sines. So to set it up, we have the sine of angle A over 6, and that's equal to the sine of 70 degrees divided by 2. Now when you cross multiply, or even just multiply both sides by 6 because that's going to isolate our angle A little bit better for us. Take 6 times the sine of 70 and then divide that result by 2 and you get that the sine of angle A is about 2.82. The next step you would do would be to take the sine inverse of that answer, and what happens is you get an error on your calculator. And there's a good reason for that error. It's because you can't have a sine value that's bigger than 1. All of trig is related to the ratio between sides and angles in a right triangle, and sine is opposite over hypotenuse. So we would have a right triangle where the opposite length divided by the hypotenuse is in a ratio of 2.82 to 1, and that doesn't make sense. The hypotenuse is never less than one of the sides. So this is a case where we're given a side-side angle, but based off the numbers we're given, there's no triangle possible. Now we're going to look at case 2. I know numerically 1 would come between 0 and 2, but we're going to do case 2 next, and for a very good reason. So in this one, we're told that angle A is 30 degrees. So what I'm doing is kind of approximating here. I'll say this is our 30-degree angle. There's angle A. Little a is 7. I'll get to that last because it's going to be opposite to that. And then little b equals 8. So now what I'm going to do is start here and say, let's let this length be equal to 8. And that's going to be little b, so angle B is down here somewhere. And then the other thing that we know is that little a is 7. So opposite of this angle, so coming from this point, we have a length of 7. Maybe the 7 should go like this, or maybe the 7 should go like that. So we could have potentially this green triangle, or maybe that purple triangle. It's unclear or ambiguous, so in a case like this, we may have more than one triangle. I'm still not quite sure yet. My drawing was done kind of sloppily and wasn't drawn to scale. So I have to go through the algebra and through the trig to see, is there a triangle? If so, could there be 2 triangles? And let's get started on it. We're going to use the law of sines, first of all, to find angle B. Now, one of the rules that we don't want to break normally is we don't want to use law of sines to find the largest angle. However, I'm going to have to break this rule. In this case, the side-side angle is weird, and this is one of the reasons why. The best way to start this one is by using the law of sines. So we would say that the sine of angle A, which is 30 degrees divided by 7, is equal to the sine of angle B divided by 8. So if we start solving that, cross multiply 8 times the sine of 30, divide that by 7, take the sine inverse, and we get that angle B is about 34.8 degrees. So unlike case 0 where we got an error, this time we actually have an answer. We're going to store that value into the calculator because we're going to use it a little bit later. And we're going to see, could in fact there be another triangle? What I need to do with this 34.8 degrees is subtract it from 180. So take 180 minus that answer, or 180 minus the stored value, and you would get 145.2 degrees approximately. So what we're saying is maybe angle B is 34.8, maybe it's 145.2. The calculator doesn't know the context of the problem that we're working on. So when you took the sine inverse, the calculator defaulted to giving you the acute angle. However, the angle might be obtuse. And what's unique about these two angles is that they're supplements. They have the same sign. If you took the sine of 34.8 and the sine of 145.2, you would see that they have the exact same sine value. And because 8 is bigger than 7, we know that angle B is bigger than 30 degrees. We don't know if it's just a little bit bigger or if it's a lot bigger. So we did this, and the next thing we're going to do is look at the numbers that we have. A must be 30, little a is 7, little b is 8. Is it possible that angle B is 145.2 degrees? And here's the check. In every single triangle, we know that the sum of the angles equals 180 degrees. And if I add up angles A and B together so far, that doesn't come out to 180 degrees, which means that there is something left for angle C, which means that we are going to get a second triangle for this one. So to continue with this one then, we're going to use that 30 degrees we had from the beginning, and this answer of 145.2, the exact number in the calculator, which is actually 145.1500 and so forth. We're going to take 180 minus both of those values, and we would get that angle C is a very small angle of about 4.8 degrees. One more step in this one, we have to find little c, and to do that we're going to use the exact values from A. The sine of 30 over 7 is equal to the sine of that 4.8 number that's still in my calculator, or I could store into my calculator. Cross multiply, so it's 7 times the sine of that answer, that c value, divided by the sine of 30 will give us that little c is about 1.18. So there's our second triangle. Now we have to go back to the first triangle and finish solving that one. The process is going to be the same. We'll take 180 minus 30 minus that stored b value we had in our calculator from the very beginning. I don't want to use 34.8 because if I use this number, I'm using a rounded number and it's going to taint our final answer and it's going to be off by too much. So angle C is going to be 115.2 degrees. It's actually 115.15. And now we're going to set up another law of sines. Sine of 30 over 7 equals the sine of this c value divided by c. So once again, we're going to cross multiply to solve. 7 times the sine of that answer, or the stored value, divided by the sine of 30 gives us, in this case, that c is about 12.67. I'm going to do one more check in a problem like this, and it pertains to each individual triangle. So we have this triangle to consider. Smallest angle, smallest side. Largest angle, largest side. So that's nice and consistent. And then in the other triangle, we have smallest angle, smallest side. And largest angle is across from the largest side. So that's all nice and consistent. So I'm feeling pretty confident that my answer here is correct. And we have one last case to consider. This is case 1, which means that there's only going to be one solution to this one. Looking at the numbers right away, maybe I wouldn't be able to identify that, but we're just going to jump right into the problem and start solving it the same way we solved all those other ones. We're going to try to find angle B by using the law of sines. So it's the sine of 50 degrees over 12 is equal to the sine of angle B divided by 7. Cross multiply, so we're taking 7 times the sine of 50, dividing that by 12, and then taking the sine inverse of that angle, and we get about 26.5 degrees for angle B. Okay, we have one of the angles. What I'm checking for next is, could there be a second triangle? And the way we went about doing that is we took 180 minus this answer that we got. So 180 minus this would give us about 153.5 degrees for another triangle. But there's no way that angle B can be that big for a couple of reasons. Number one, 7 is less than 12, which means that angle B must be less than 50 degrees. So there's one problem we have. The other big problem is that there's only 180 degrees in the triangle. And since angle A must be 50 degrees, there's no way our second angle could be this big because we would already add up to more than 180 degrees. So in this case, we're only going to get one solution. To finish it off, we have 50, and then this last answer in our calculator, 180 minus that answer minus 50 degrees, gives us 103.5 degrees for angle C. And then we'll use the law of sines. Sine of 50 over 12 equals the sine of this last answer we got. You can either store it as C or just keep it in there as the answer, divided by little c. It's 12 sine of that answer divided by the sine of 50, and we get about 15.23 for this length. And again, one quick check, smallest angle, smallest side, and the largest angle is across from the largest side.